It's like I don't care about nothing, man. Yeah. Oh,
So this video is going to be about how to find equations and trying to figure out what the equation for the line is going to be if they are parallel. So this video is going to be about being parallel. The next video will be about perpendicular. Okay, so first problem that we're looking at on this page is number 4 on page 28. It says in rectangle EF, GH, EH is parallel to FG, and EH crosses the y-axis at 0, -2. If the equation of the line containing FG is x plus 3y equals 12, write the equation of the line containing EH in slope-intercept form. Show your work and justify your answer. So first things first is I know a lot of my students are always intimidated whenever there is a word problem. So something I always suggest is to draw it out. So they say we have a rectangle. So if I have a rectangle, we're saying that it's rectangle E, F, G, H. Now EH and FG are supposed to be parallel. So one way I can show they're parallel is by doing the little filled in triangles on each of those lines. So these lines are supposed to be parallel. They gave me an equation for EH. EH is, or sorry, a point for EH. It crosses the y-axis at 0, -2. The equation for FG is x plus 3y equals 12. So right now I know that the equation for this line is this. It's in standard form. So when it's in standard form, the way that we can find the slope for it is by the opposite of A over B, just like we talked about in the last video. So opposite of A means whatever's in front of the X. We just change the sign, so there's an invisible 1. So I'm going to have -1 over B, which is 3. So my slope is -1 over 3. So again, this is my slope. Now, if they're parallel, the slope has to be the same. So I know when I create the equation for the other line that the slope has to be the same. So that's if they're parallel, which they told us they are. So when I do this, I'm going to use, to solve this, point-slope form. If you don't remember point-slope form from the pages earlier, that is y minus y1 equals m times x minus x1. So in this case, this would be my y1. This would be my x1. Now I just have to plug it into the equation. So y minus a -2 equals -1/3, because that was the slope, x minus 0. So since you have minus and negative, the sign changes, so really we have y plus 2 on this side. And then over here what I need to do is do distribution. So on this side, like I said, we have y plus 2 equals -1/3 x, and then -1/3 times 0 is 0. So you don't have to write it, but I'll just go ahead and write it and say plus 0, because anything times 0 is 0. Next step is, if I want it in slope-intercept form, slope-intercept form is y equals mx plus b. Right now I'm close to that form, but I need to get y by itself. So what I'm going to do now is subtract 2 from both sides, And what I get is y equals negative 1/3 x minus 2. So in this problem, if I wanted to create the equation that goes through that point in slope-intercept form, this would be my answer. And we kept the slope the same because they are parallel. So the next problem that we're going to do is page 29, number 6. On this one, it says write the equation of a line in slope-intercept form that contains Q, which is at 5, 1, and is parallel to the line MN, with M being at negative 2, 4, N being at 2, 1. Then graph the two lines. So first things first is if I want them to be parallel, they're going to have the same slope. So I'm going to first have to find the slope of this. So if you don't remember the formula to find slope, it's the y2 minus y1 over x2 minus x1. So I'm going to give a value or give an x1, y1 and an x2, y2 distinguish on these. So I'm going to say this one is x1, y1, this one is x2, y2. Didn't matter which one I made that, but that's just what I went ahead and did. So y2, we had 1 minus y1, which is 4, over x2, which is 2, minus a negative 2. So what we have here, 1 minus 4 equals negative 3. And when it says minus a negative, what happens is we would then want to change the signs. So this would be actually 2 plus 2, which is 4. So the slope of this line is negative 3 over 4. So now I'm going to use this slope to find the equation in slope-intercept form for this. So the way I'm going to do that is by using that formula that we used on the problem before, where it was the y minus y1 equals m, and in parentheses x minus x1. So this is the one we're going to use for this. So y minus 1 equals negative 3 over 4 times x minus 5. So this is what we're going to use to solve this. So first things first is I'm going to distribute the negative 3 over 4 into everything. So I have y minus 1 still on this side, negative 3 over 4x, and then negative times negative is positive. And if you don't know how to multiply a fraction with a whole number, we put it over 1. Numerators multiply together, denominators multiply together. So negative 3 times negative 5 is 15 over 4. So we are very close to being done with this problem. But what I want to do now is, since they want it in slope-intercept form, y has to be by itself. So what I'm going to do is add 1 to both sides. And I'm going to rewrite it because a lot of people I've noticed in my class are not very comfortable with adding fractions. So y equals negative 3 over 4x plus 15 over 4 plus 1. Now, whenever you add fractions, you have to make sure they have the same denominator. So any whole number can be put over 1. To make it so they have the same denominator, I'm going to multiply the top and the bottom by 4. So now I would have y equals negative 3 over 4x plus 19 over 4. And that would be the equation for this in slope-intercept form. So the other part of this one was to actually draw the lines. Instead of me drawing it on there, I figured I would just put it up and then show you how I got it. The way I found the original line MN is I just plotted these points M and N and connected and just made a line going through them. So that made that line that I wanted. To find the line that's supposed to be parallel to it, since I already found the y-intercept, I went ahead and plotted that. It came out to 4.75 is what this equals. And then Q was at 5.1, so I plotted that and then just connected the lines. And if you notice, when I go down, it does go down 3, to the right 4, just like our slope was supposed to be. So that is how you would plot those points as well. So now it should be truly reinforcing you that if they're parallel, they're going to have the same slope. So you'll notice that in both of the problems I went over, we used point slope form. So when you have a word problem and you have to find and create an equation, typically you're going to use that form. But first you have to find your slope. So the next video is going to be all about being perpendicular.